Hello, and welcome to the first edition of the Medeek Engineering plugin. My name is Nathaniel P. Wilkerson, and today I want to introduce you guys to the latest extension that I've been working on, which is called Medeek Engineering. So let's start out first by heading over to the website, and I'm going to go ahead and go to the Resources tab. And you'll notice with the Resources tab, all the extensions are listed here, starting with the Medeek BIM bundle, which is 5 extensions. I'm sure most of you guys are aware of these. And then below that, you have the MET bundle with the plumbing still pending. And then just right below that, we now have the Medeek Engineering extension, which is, as you can see, still in beta, which means that it's, I wouldn't be using this for production work quite yet at the time of this video, which is November 12th, 2025. But we are certainly getting there. So let's go ahead and click into that page. And then, as you can see at the top, I've said this extension is currently in development, beta release. So yeah, I'm still doing a lot of testing, making sure things are working correctly, making sure the calculations are all correct. But to start off with, I just wanted to at least put this video out there to show you guys where we've gotten thus far. So I actually started this extension back in 2021. I think it was in April. I released the initial release, and at that point, all we could do was add in some point loads and distributed loads and supports to beams that were created within the wall plugin. And since then, of course, I've been working on the actual analysis engine and the reports. And currently, at this time, the beam calculator should be able to compute dimensional lumber beams. So that's what we're going to demonstrate today. All right, so with that out of the way, let's go ahead and jump into SketchUp to show you guys how this all works. So first off, let's go ahead and we'll use the project extension, Medeek project, throw down a grid, and I'll just pop a grid over here just so we have something to work with. First off, before we can get to that, let's go ahead and look at the toolbar. Well, actually, there's two toolbars. So the main toolbar actually right now is very minimal. As you can see, all it is a global settings toolbar. And if you click on that, you have your typical global settings that you'll see in all of the other extensions. Annotations, some user interface stuff. You also see layers. And again, this is still quite a bit under development. I haven't quite determined what layers I'm going to need. I kind of borrowed actually from HVAC layers, so that right now is listed. But what is most important, though, is the EOR section. So this will allow you to basically set up your company logo, the name of your engineering business or your architectural business, and a bunch of other settings. So these will automatically populate the report that is created with the beam calculator. So this is an important piece. And eventually I would like to add in, right now it's under construction, a section for customers so that you can add like a customer database in here. And so you can quickly load up, a customer's information, like usually the project site or location, their name, maybe some other details. All right, I think that's about it. Most of this is still under construction, but just to show you that it does have a global settings, just like the other extensions do. Okay, so let's jump over to the more interesting part. I'm going to go ahead and put these toolbars back here into the document here. So this toolbar here that I'm showing you is the the beam calculator toolbar. Okay, so the first things first, as far as beams go, you're going to be using, well, currently all you can analyze are beams created within the wall plugin. So if you go here to draw beam, and I'm going to just give it a second to load. Okay, so this is coming from the wall plugin. So you can create beams, and we're going to just go ahead with a regular sawn lumber. Let's say a 2x10, and let's make it a number 1. All right, we'll just keep all the rest of these things default. Let's turn the advanced options off just so we don't overly clutter things. And then I'm going to draw, let's just make a small 12-foot piece here. Okay, so there's our 12-foot piece of lumber. Now, as of this making of this video, like I said, all we can analyze right now are sawn lumber beams. So, and you can do multi-ply beams as well. So 2x4s, 2x10s, 4x4s, 4x6s, that sort of thing. As I keep developing this, obviously we're going to have timber beams you can do, glulam beams, LVLs, PSLs. So that is in the works. Again, this extension is very much under development. Okay, so first off, the first thing you'll notice is this is just a typical beam drawn in with the wall plugin with the beam module, which is this icon right here. And so you're basically working with geometry created by the other extensions, and in this case, it's the wall extension. So what I'm going to do first is I'm going to click this button here, which adds loads and supports. Okay, so you come up with three options here. So I'm going to start with the supports first. Just click support. And then as I mouse over the beam, you're going to notice the beam highlights, and then it shows like this little positioning skeleton, I guess, or graphic to where you can place the first support. And again, you can set these supports, column, beam, whatever. And we'll just leave it as default for now. You can add a description, that sort of thing. And also, you have the hotkey here. I should mention that you click the control key and it will allow you to toggle between centering and edge. And I'll demonstrate that. So I think it's by default set to centering. So if I click my first point, and then you notice I can stretch this to set the support width. So I'm going to just put in, let's say 3.5 here. Let's see. Okay, and I think my measurement thing is smaller than normal. I'm not sure why I'm not seeing that. Probably because I have too many icons here. Okay, so there's my first support, right? And you'll notice the support is created, it's actually, sorry, I'm bouncing all over here. It's actually creating these, the geometry within the beam assembly itself. So it's part of that. Okay, so let's go ahead and create another support. Let's see here, click this again. And you can creating supports. I just jumped out the tool by accident. So I'm going to go put one on this end, 3.5. Now, let's go ahead and put one on this at the center. And you'll notice if I hit the control key right now, it's basically setting from that side. But I kind of want to do I prefer the centering system myself because it seems like it's just easier to work with. But anyways, I may add other options in there. Okay, so now we've got our supports added. Now, granted, if you have less than 2 supports, the beam calculator will not work. And the reason being, of course, is it would be indeterminate, right? You can't compute calculations on a beam that only has 1 support or 0 supports. So you need to add your supports in. And at some point, I may have an option like where we have beams that are sitting on other beams and that sort of thing to auto insert supports. So that is something, kind of in the works, but I've got to, it's going to be a complicated algorithm. I'll be working on that. All right, so there's our supports, really easy. And again, it doesn't matter what order you put those in. Notice it's out of order, and you can adjust that, however you want to do that, but that doesn't matter. Let's now look at adding a point load. Okay, so when you bring up the point load option, you'll notice that you have all your 6 typical loads: dead, live, floor, live roof, snow, wind, and seismic. All right, let's go ahead and maybe set this like to 500 just to change it up a little bit, the default. And then as you mouse over your beam, you're going to notice that it just kind of puts this little graphic, and you can position it wherever you want. I'm going to center it over this span right here. Okay. And you'll notice too that as it creates that little point load, it will put in the actual set or the actual values for you, right? So let's go ahead and edit that just to show you how that works. Okay, and I'm not sure why this menu is so large, but I need to adjust that. Okay, so you can see we can adjust these loads. We can, obviously edit things as we need. Let's put 300 in here. Okay, and so now you see we've got basically it's represented. We have the snow, the live, floor, and the dead. Okay, all right, last but not least, let's add in a distributed load. So very similar to adding a point load. You click here. Let's just up that to say 50, make it a little more. And this is going to be in pounds per feet or or pounds per lineal feet, PLF, as we often say in the trade. So basically, this is your start point, and then this is your end point, right? So the green means it's your start point. So we're gonna start with a load here, and then I'm gonna come out here, stretch out here, maybe put it right there. It doesn't really matter. And that's your distributed load. So that's a rectangular distributed load. There is no other distributed loads right now. There's no triangular loading or parabolic loading or anything like that. I mean, at some point I may add that in, but for now we just have regular uniform distributed loads, right? And and by the way, I do not have a metric version of this as of yet. It's all imperial units, so your typical American calculations. And as you'll see, we're using the what is it now? The AWC and basically IBC, right? So NDS for the wood from AWC, and then the ASCE 722. So again, it's all kind of American engineering, I guess. All right, so now we've got ourselves a loaded beam with that's supported, and so now we're ready to run some numbers, right? And again, you can delete these loads. Here's the delete button. Supports, you can delete loads and supports with this one button. You can edit them, and you can actually move them. So let's go ahead and try the moving. So I'm going to move this over, let's say a foot over, and that's why I'm using this grid. You notice how nice it is. It snaps to this grid really nice. So there you go. So bingo, you can move things around. All right, let's go ahead and I'm going to save this right now. And then I am going to run it. So to run it, it's very simple. There's a little engineering calculate beam icon right here. Go ahead, click this icon, mouse over the beam, it'll highlight. And then what's going to happen is you're going to pop up this little kind of input screen where you can add in and you can tweak certain things. So obviously it's pulling all of the information about the beam already, and that's already stored within the attribute library for the beam. So it already knows it's a number one, all that. But here is where you can start getting interesting. So I'm going to change this to laterally embraced for both top and bottom. And self-weight, notice we can turn on and off the self-weight of the beam. So we can turn that off if we want. And by the way, you'll notice how it turns red. So you want to hit update once you make a change so that it actually is using that information. Here I'm just going to put in beam design. This will appear at the top of the report. Maybe a job number. I don't know. Let's just say 2. And then typically, you're going to want to put in a date. So this stuff, I may set it up so it auto-populates. Revision, I'll just leave that blank. And then let's say customer name. Let's just say John Smith. And then 123 South 225 West. I don't know, Provo, Utah. 84604. Okay, so we're basically populating some of these fields here. But like I said, the nice thing is the engineering information that you put into the global settings will populate here. I'm going to set the...
I'm not quite sure how to help you with that.
Hold on one second. Sorry about that. I think my Alexa was listening too much to me. All right, so back at it. As you can see down here in the advanced options, by default, I think I have this set to simple. And I need to set this up in the global settings so somebody, a user can set this to however they want it to be. But right now we're going to run with the detailed analysis so that we get all the pages. And I'll demonstrate what that involves. Okay, so there you go. That's basically all of your beam engineering information that you're going to use for your report. So let's go ahead and we'll just go ahead with all this. And then, once you mess with that or set all that up, you just click calculate engineering. Okay, and there you go. So basically it's taking this beam, it's taking all the parameters and all the settings and properties of that beam, and it's basically run all the loads. And we've got our reactions, our shear, our moments, deflections, total deflections, our live load and total, and then a bunch of other information here with regards to the supports and the loads that are applied. And again, this is brand new. So, I'm still testing it. I'm still making sure that there's no gotchas or anything miscalculated. But I've been working on this now since August. So it's been about 3 months, I guess. So I'm pretty confident in the results. But again, I would suggest to you, still in beta. So please don't use this quite yet for, a production environment. But certainly give it a shot. Test it up against other softwares out there, and we'll see what we have. But basically, it's quite similar to other softwares like Forte Web or BC Calc. There's a number of ones out there that are free, of course. But what I'm excited about is the fact that you can do that with a simple push of a button. You don't have to input all that information into these other third-party softwares. So we're keeping basically all of the geometry and now the engineering within SketchUp itself. Okay, so this is the full detailed report. You're going to have these first 2 pages, which will be in the simple report, kind of just beam information, and kind of the summary page, which is on the front page, which is the most important. And of course, here we notice it passed. And there's 6 tests it's essentially running, and if it passes all 6 tests, then the beam will pass. But now let's scroll down here and take a look. We've got ourselves adjustment factors. We have computation of self-weight. And then we get into the more interesting stuff, in my opinion. This is where we have the actual shear and moment diagrams, as well as the 2 deflection diagrams for the live load and total load. And you'll notice that there's a little drop-down box here. And I'm going to show you that here in just a second, but I'm just taking a look at all the other so there's a little drop down box here, and you can actually take a look at your different load combinations or load cases, and you can run the numbers there and take a look at that, and you'll see all the values being represented. So again, when you print the report, you're only going to get the one that is currently shown. And again, as you can see, you can mouse over, you can actually pick out different values from these graphs. So it's kind of cool that way. Took a little while to figure all that out, but that's what I do. So there we go with our deflection curves, and again, same thing here. You can change up different load combinations to see what exactly those values are at those particular load combinations. Yeah, well, it's kind of interesting. All right, and then of course down below that we have the computations that calculate the kind of the worst case load combo, and it shows you which load combo you're using and what value at X you are at for like the shear and the deflections. And then also when we start talking about bending, we actually have we're computing for the negative bending as well as the positive bending, checking both of them. And it looks like they both check out in this case. And then last but not least, you have the reaction, the worst case bearing reaction being checked. So 9 pages overall with the detailed report. As you can see, it's quite verbose, quite extensive, because I do like to show all of that detail, all of those calculations, so you as the user know exactly how I'm coming up with these numbers. I'm not just pulling them out of my hat per se. All right, so that's the detailed report. I'm going to go ahead and change this now to just a simple report to show you guys that really quick. This video is already getting kind of long. Hit update on that, and then if you go ahead and calculate engineering, now you'll notice that you only have 2 pages, and then the disclaimer is actually at the bottom of this page instead of at the bottom of the 8th or 9th page. So much more abbreviated report. I tried to get all on one page, but unfortunately there's just too much information, and I wasn't able to squeeze it all on one page. And I'm still working on that, and I might be able to do that in the future. But for now, we have basically a 2-page simple report. So that's where I'm at with that. The one other thing that I wanted to show you guys is the option here to switch from a Euler-Bernoulli, which is kind of the classical way that most of these calculators run. You also have the Timoshenko analysis, which also, well, it's not that much different really. The values, it may be only maybe 2 to 3%, maybe 5% at most. Typically, you're only going to need this if you're doing really deep and short beams. So I wouldn't actually suggest it in most cases, but for the I don't know, the really particular engineers that want to really nail down something, they may want to use that option. And if you do that, you'll notice, actually, we need to do the detailed report, don't we? If we go to the detailed report on that and then go ahead and compute that, you'll notice that your values, yeah, I mean, they're slightly different. Your reactions are going to be slightly different because it does impact the matrix analysis slightly. But what you'll notice is the discontinuities are in the smoothness of these deflection curves primarily. But again, you're talking only a small percentage of difference. So most people are only going to be wanting to use the Euler-Bernoulli method analysis. And by the way, that is shown which method analysis you're using right here under design method. And of course, your code standards. All right, so I guess I could go on all day about this thing, but mainly I just want to show finally you're going to ask, well, okay, great, I got the report. Now how do I print that, or how do I do that? So I don't have a print button here. The easiest thing to do is just right click on this window and click print, and then you can print, of course, directly to your printer. Usually what I like to do though is I will print to a PDF. And just go over here, usually you have the PDF option, click apply or whatever, and then go ahead and print that. And now you'll notice by default it will assign the job number and the title to the other thing, as well as including the revision number if you have included that. But in this case I haven't, and that's fine. And you can set that whatever you want to, save that file name to whatever, but it might take just a couple seconds here while it spits out this PDF. Just giving it a bit. There's a lot of pages here. I mean, so it takes just a second. Okay, so dump that over the other window. So there you go. There's our PDF, and you'll notice it's kind of a little different than how it's being displayed. It's got it in a frame, which is this is the way I used to do my reports, and I like to do it this way because what I can do is when I actually print this physically out, I have enough room here on the left margin where I can hole punch it and then put it into either a binder or put it into like a little presentation folder, which just makes it really handy and useful to use. So again, that's pretty much it as far as the actual beam analysis, but I just really wanted to show you guys kind of where I'm at so far. Again, there's still more work to be done. This thing is definitely in development. I've been working on it hard for the last 3 months. So again, test it out. Let me know what you think. We are limited only to sawn lumber at the very moment, but working on trying to include glue labs and everything else. And that is my goal here in the next few weeks. Again, guys, thank you for your support. And if you have any questions or feedback, I'm always open to it. In fact, that is what makes these plugins, extensions, makes them push forward as far as they've gone. And we will talk to you guys later.